We're given the graph of f, and we want to fill in the missing values here. So first, for the first derivative and then the second derivative, we want to indicate whether it's positive, negative, or zero. The first derivative will tell us if the function is increasing or decreasing, and the second derivative will tell us about the concavity. So if the first derivative is positive, that means f is increasing. If the first derivative is negative, f is decreasing. And if the first derivative is zero, it's not increasing nor decreasing. So just think of it as flat. Now the second derivative, if that is positive, we know it's concave up. That is, f is concave up. If it's negative, f is concave down. And if it's zero, it's just a straight line. Okay, so with that in mind, let's go over these. First, we're going to pay attention for x being between -5 and -3. We know that this function is increasing, so the first derivative is positive. The concavity is 0. There is no concavity here because it's a straight line, so the second derivative is 0. Now from -3 to -1, the function is decreasing, so the first derivative is negative, and it's concave up, which means that the second derivative is positive. Now from -1 to 2, we know that the function is increasing, so the first derivative is positive, and it's concave up, so the second derivative is also positive. From 2 to 5, my function is decreasing, so the first derivative is negative, and it's a straight line, so there is no concavity, so the second derivative is 0. Now for part B, we want to see why this does not violate the mean value theorem. Because the mean value theorem would say, okay, there's a value x in the open interval from -1 to 5 such that the slope of the secant is equal to the slope of the tangent. This is saying that there is no value that satisfies this equation. Now, for the mean value theorem, there are two conditions. F has to be continuous on the closed interval, and it has to be differentiable on the open interval. So if you have these two conditions, you're guaranteed this equation. So we have to check that these two conditions are met. So first, is f continuous on that closed interval? If we go back up here, if I was to graph this from -1 to 5, it is very clear that this is continuous, since I can graph this without lifting out my pen. So yeah, this is continuous, but is it differentiable? Let's see. We know that we did find out the derivatives between basically the endpoints. We did not consider from -1. We did not consider -1 and 2, and we're not going to include, I guess 5 too. So we're looking from -1 to 5. Is this differentiable? Clearly, -1 it is, but we don't have to consider the endpoints actually because we have the open interval. So I guess any point between -1 and 5, is that differentiable? Really, the only question here is at x equals 2. What we have here is a cusp. We know that the derivative does not exist when there is a cusp. So it is not differentiable in the open interval. So because the criteria is not met, we cannot use the mean value theorem. Therefore, it does not violate the mean value theorem. So what I would say here is since not all the conditions are met, for mean value theorem,